Welcome. Today we are solving square root and half power equations. So these are all equations, yes, involving square roots or half powers. We will have to check for extraneous solutions in here, which that means solutions that can actually result from the algebra but actually don't work in the original equation, and I'll show you how to do that soon. All right, so first thing you want to do here, take a look at your equation and think about how can I solve for the variable here? And usually it's how can I get x by itself? Well, I need to get rid of these square roots. Since I just have a square root equal a square root, what I can do to get rid of those is simply square both sides. And so I get 2x minus 3 equals x. And just like that, now I just have a regular linear equation. I can solve for x. So I'll probably take away 2x from both sides to do that. So I have the variable on one side and the constants on the other side. So this comes out to negative x, or negative 1x. And then, yeah, you divide by negative 1 so that this comes out to x here. And so we get 3. Now we need to double check that that actually works in our original equation. The other piece of the directions that I didn't read, it said recall the domain for a square root function is restricted to positive values. If, as a result of putting in this answer into any of the square roots in the original problem, if you get a negative result, well, that is not going to work. You'll have these are only involving real numbers here. We don't have the imaginary numbers involved in these. So if you end up getting a negative square root, that means the answer is extraneous. So let me go ahead and do that here. I'm going to put this 3 into the original equation. So we'll go 2 times 3 minus 3, and then that equals square root 3. So here, 2 times 3 is 6 minus 3, well, that'd be 3. So it works. You don't have to go ahead and you don't need to type that into the calculator and figure out what the square root of 3 is. I can clearly see that this works. I get a positive number underneath the square root, and both sides are equal. So we don't have any extraneous solutions, so that is a valid answer. All right, let's do number 2. Here we have a half power. Yeah, that's nothing more than just a different way to write a square root. So if you want to, you can go ahead and just write it as a square root. That's what I like to do. Then we just need to, this is a little different though, comparing this equation to number 1. Notice that when we have a square root on both sides, here we just have a single square root. So I need to, in order to use the technique of squaring both sides, you have to make sure that each side just contains a square root, or in this case it's only going to be one side that has a square root, but either way I need to isolate this square root on this side. So I'm going to add 2 to both sides first. You wouldn't want to square at that step because squaring this would be like squaring a binomial. It'd get really messy and wouldn't actually help. So isolate that square root first. And so you get square root of x plus 5 equals 3. Now we go ahead and square both sides. And so we'll get x plus 5 equals 9. And yeah, now we just have a linear equation. We get x by itself. And so we get x equals 4. Once again, we need to make sure that this works in the original equation. So I'll go ahead and put that in. It doesn't really matter if you use this equation or this one. I'll go ahead and use the original. So we're going to have 4 plus 5 to the 1/2 minus 2. Does that equal 1 here? Well, let's see. We're going to have 9 to the 1/2 minus 2. And yeah, 9 to the 1/2 is 3. And yeah, we can see that this is going to come out. And be 1 equals 1. All right. Okay. So let me do this next one. This one's actually similar to number 1. I'm going to go ahead and change these to square roots. That's what I like to do. You don't have to do this, but it just makes it easier for me. All right. And now this one, why I say this one is similar to number 1, we have 2 square roots in it. Luckily, what we can do is just add or basically move one of the square roots to the other side, and then it'll look very similar to what we had in number 1. So yeah, you can go ahead and like add this as like a single term here to both sides. You can do that. And so you end up with the square root of x plus 6 equals square root of 2x minus 4, and then you just simply square both sides. And so you'll get x plus 6 equals 2x minus 4. And we need to get the x's to one side. I'm going to go ahead and take away x on both sides. So we'll get x minus 4, add 4 to both sides, and we get 10 equals x. Once again, we have to make sure this works in the original equation. Looks like I have a little space over here, so I'll do it over here. So let's go ahead and put that in the original equation. So 10 plus 6 to the 1/2 minus 2 times 10 minus 4 does that to the 1/2. Does that equal 0? All right, so this is going to be 16 to the 1/2, and then 2 times 10 is 20, minus 4 would be 16, so I have 16 to the 1/2. Yes, we can see, I mean, we'll go ahead and take the 1/2 powers. We don't have to really have to do that, but either way we get, 0 equals 0 there, all right? Okay, number 4 is a little different here. We're going to go ahead and take away 2 from both sides. We want to isolate that square root first in order to use that technique of squaring both sides. Notice we have a binomial over here. We have x minus 2. When we go to square both sides, it's going to be a little different over here. This is just going to be x plus 10 over here, but over here we have to basically FOIL this out. If you recall, this is like x minus 2 times x minus 2, so you're going to have to FOIL this out, so you get x squared, and then negative 2x, and another negative 2x. I might just do those together. So yeah, we got negative 2x, and then another negative 2x. That's going to be a total of negative 4x, and then we have negative 2 times negative 2 is positive 4. All right. Now we have a quadratic equation, not a linear equation. So the technique here generally is to get everything to one side. So we're going to do that. We're going to go ahead and take away x and 10 on both sides. Boom, boom. And so we get 0 equals x squared minus 5x minus 6. And so you could either use the quadratic formula here if you wanted to. Complete the square factor is sometimes works. I think factoring will work here. If we can find two numbers that multiply to negative 6 and add to negative 5, we can do it. Yeah, that's going to be negative 3. No, I lied, yeah. It's going to be negative 6 and positive 1. There we go. All right. So yeah, x minus 6 times x plus 1. And now that means our answers are, I'm going to do it over here because I know I need a little bit more room for checking the answers. So the answers would be negative 1, right? Because negative 1 plus 1 would give us 0, which would zero out this whole side. Or it could also be 6. That would make this 0, and 0 times whatever would zero out that whole side and make the equation true. Okay, so we have negative 1 and 6. And we need to check to see that both those work in the original equation. So let me go ahead and plug in the negative 1 first. So I'm checking here. Okay, so we're going to go 2, and then this is going to be square root of 9. Does that equal negative 1? 2 plus, this would be 3. By the way, on all these, it's the positive square root. We're using the square root function, so it's always just the positive square root. We don't worry about, like the square root of 9 doesn't come out to positive or negative 3. We're using the square root function here, so we just consider the positive square root. All right, so we have this. Ooh, this does not look like it's going to work. We have 5 equals negative 1. Well, that is not true. So that is an extraneous solution. So yeah, really the only way to find those extraneous solutions is to check them in the original equation. So we're sort of forced to check our answer here. All right, let's check and make sure the 6 works. So we're going to put that into the original equation. Okay, so notice, yeah, that 6 is going in 2 places, right? It's going in here for x and here for x, all right? So here we're going to have square root 16, and then the square root of 16 is 4, and yeah, this looks like it's going to work out. Okay, so really only our only answer then is x equals 6 on this answer. Okay, the negative one was extraneous. All right, you guys go ahead and do numbers 5 and 6, and then I'll show the answers after you do them. All right, what I got on number 5 here was negative 5. So yeah, basically you start out by adding this to both sides, and then you square both sides and go from there. And this was not an extraneous solution. I checked it. And then over here, isolated the square root. I changed that to a square root just to make it easier for me. And then I isolated the square root by adding 9, squared both sides, solved for x, and checked my solution, and it worked out. All right, so I got x equals 100, number 6.